Welcome to the sixth lab of this course. We'll observe the characteristic of diodes and implement a few application circuits of it. Experiment 1. In this experiment, we're going to observe the IV curve of diode. Construct a circuit and input a 10 volt 10 kHz sine signal into the transformer. Connect the ground of the oscilloscope in the middle of the diode and the resistor. Channel 1 on the other side of the diode, and channel 2 on the other side of the resistor. This will enable us to observe the voltage cross the diode by channel 1. The channel 2 gives us the voltage cross the known resistor, which enables us to calculate the current passed through the whole circuit. Note that because we're measuring the voltage in the opposite direction of the current, we have to invert the input of channel 2. We can easily derive from the equation I equals to V divided by R that when R is a constant, the voltage is proportional to the current. It is clear that the voltage cross the resistor represents the current through the whole circuit. Therefore, we could treat it as the current and draw the IV curve using the channel 2. Details of changing to XY mode are as below. Set both channels to DC coupling and align them. Remember to invert the channel 2 waveform, then change the mode into XY mode. If correctly aligned, you can observe the IV curve of the diode clearly. By align, I mean that aligning the zero ground of channel 1 and channel 2 to central of horizontal and vertical axis. You can use the cursor function to find the voltage of channel 1 and channel 2 in order to get the cutoff voltage and current. When measuring the Zener diode, if you can't observe the breakdown voltage, it is probably because the voltage isn't large enough for the diode to break down. Therefore, turn the voltage to maximum. If you still cannot get it, then try a higher frequency, since the transformer has better efficiency in high frequencies. Now, let's look at the bonus lab. In this experiment, we want you to measure the efficiency of the transformer using 10 kHz input sine wave. Then we'll measure the frequency response of the transformer by sweeping the frequency from 10 Hz to 100 kHz around 100 milliseconds. You shall find the response is very low while the frequency is below 100 Hz, and the response will also decrease after 100 kHz. Measure the inductance and ESR of both sides of transformer using the RLC meter. These values will help you understand why does the quality factor changes with the frequency. Also remember to record the measuring frequency and quality factor. This is a simulation of the experiment. Using the parameters shown in the figure, the inductance and transform efficiency may vary. Therefore, your result will be slightly different from this figure. The efficiency of the transformer is related to the high frequency response. Here we set the efficiency to be 0.99. Therefore, you will see the frequency response decreases at 10 kHz. If the efficiency is 0.999, then it will decrease at 100 kHz. Experiment 2. Complete the regulator circuit and input a triangular wave of 1 kHz with the following settings. Apply different resistor on RS and record the Vs and Vout. Calculate LIR and the resistance of Zener diode. The definition of the LIR is the peak-to-peak voltage of output divided by the peak-to-peak voltage of input. In order to make better measurements, we want the amplitude on the oscilloscope to be as large as possible. Therefore, we'll use AC coupling. Also, adjust the setting to resist noise. Calculate the LIR and RZ and record the value of the lowest LIR. Next, use 100 ohm on RS and apply different load resistor on the circuit. We'll observe the LOR in this part of the experiment. Change the input into DC voltage. Measure the Vout with the highest precision, either with the oscilloscope or your multimeter. You will observe a small decrease of voltage. Divide Vout by RL, you'll get IO, and calculate IZ. The definition of delta Vout is the difference between two Vout. Calculate and fill in the rest of the table. Because when we use the 100 ohm resistor, the Zener diode may not be in the breakdown state. This will make the RZ very high. Therefore, we will not use the 100 ohm result to calculate our LOR. Use the 1K to 200 ohm to calculate our LOR and the effective RZ in the regulator circuit. This is the simulation result of the LIR measurement. You'll see that increasing the RS will result in worse LIR. And this is the simulation result of the LOR measurement. You'll see that decreasing RL will result in worse LOR. After finishing experiment 1 and 2, register your info on the site. Note that there are 3 pictures required for the first experiment. Then is the second bonus lab. We'll measure the parasitic capacitance of the diode. Construct the circuit and calculate the rise and fall time to calculate the capacitance using the RC timing. Then measure the capacitance using the LCR meter. You will find that the calculated value is larger than the measured one because of the input capacitance of the oscilloscope. This slide gives you a review for how to find the RC time. Experiment 3. Complete the circuit and input a sine signal with peak-to-peak 4 voltage. Change configurations accordingly and observe the V-in, V-out with DC and AC coupling. When recording, align the input and output waveform to ground and use the same scale if we could observe the change in voltage. For some configurations, in the AC coupling mode, you have to adjust the scale in order to observe the changes. Experiment 4. Design the clipper circuit that could output the signal as this figure and input a sine wave signal. In this circuit, use power supply to implement V1 and V2. Do not connect the positive or negative to ground in the power supply. And remember to add the 1K resistor to prevent your diode from burning. Experiment 5. Implement the voltage multiplier. Input a sine wave with 100 kHz frequency and 10 volt peak-to-peak voltage. Record the V-in and theoretical V-out. Then measure the real V-out. You'll find because of the diode, the V-out measured will not be the same as the theoretical one. After finishing experiment 3, 4, and 5, register your information on the site. Remember that experiment 3 has 10 pictures, and always show necessary infos on your pictures. That's all for this lab. Good luck.